Hello again, guys. So I had a question was brought to my attention by one of the students in my college algebra class. The problem was a problem from section 5.1, which is about solving systems of linear equations. And this is problem number 29 in section 5.1. So I kind of start already writing some of the steps here, but let me just kind of bring you up to date. So basically we are asked to solve this system of two linear equations with two variables by the method of elimination method, which is sometimes referred to as elimination by addition method, because we are going to end up adding the two equations to be able to eliminate one of the variables. But anyway, so in this problem, of course, we do have some fractions involved. So obviously the first step is to try to take this system of two linear equations with two variables. And again, they're called linear because as you can see, both your variables x and y are to the power 1. The power exponent happen to be 1 on both x and y, and that's why we call them linear, because they are first degree equations. Of course, we have two of them. That's why we call them systems of two linear equations. Anyway, so what we hope to do, if you're going to use the elimination method, or again, what's called elimination by addition method, you have to make sure your system of equations, is going to look something like this. In other words, you have to have x and y term on one side of the equation, the number on the other side, the right-hand side, and also same structure for your second equation. It has to be x and y on the left, and the number, of course, on the right. Okay, so if we can take this system right here, and of course change it to that form, then we are going to be able to use the elimination method to solve this system. Okay, so the first thing I did, of course, I want to remove all the fractions in both of our equations. And as you know, the easiest way to do that is to find the least common denominator of your both denominators. So in this case, 3 and 4. So I wrote for you LCD, the least common denominator of 3, 4. Of course, 3 and 4 happen to be 12. So you multiply both sides of your equation by 12. And what that does, that eliminates both the fractions. Okay, so as you distribute 12 by the very first term, as you can see, 3 goes into 12 4 times. So that first equation is going to look like 4 times 2x minus 1 plus, and then as you distribute the 12 by your second term, the 4 goes into 12 3 times, but don't forget you do have two terms upstairs. So you might want to put those two terms inside the parentheses. That way, later you don't forget to distribute the 3 onto both terms, not just the first term. That's why I also put the top two terms inside the parentheses here, because that 4 has to be distributed by both your terms, okay? And of course, on the right-hand side, 4 times 12 becomes 48. So this is what our first equation will look like after we eliminate the fractions. So we can do the same thing for the second equation. In this case, of course, between 2 and 3, the LCD of 2 and 3 is 6. So we're going to do the same thing. We're going to multiply both sides of the equation by 6. Also, let me move this over a little bit. Equals to, I believe it was 3 times 6. Also, of course, on this side. So we're going to multiply both sides by 6 because that's the LCD between 2 and 3. And so that's going to help us to eliminate these two variables. So as you distribute the 6 by your first term, 2 goes into 6 3 times. But don't forget, you do have two terms upstairs. So you want to make sure you put those inside the parentheses. So then later, you won't forget to distribute the 3 by both terms. And also here, 3 goes in, as you distribute 6 by your second term, 3 goes into 6 2 times with the negative, and of course having two terms. So we're going to put the 2 and then again parentheses, and you put x minus y inside. And that, of course, is going to be equal to 3 times 6, which happened to be 18. Okay, so now as you can see, at least we don't have any more fractions involved. So now we still have a little bit more work to do to put this or change the system into that form, but we are definitely getting closer. So the next step is to remove all the parentheses in both of our equations. So we do that by distributive property. So as you distribute, of course, 4 times 2x becomes 8x. 4 times negative 1 becomes negative 4. 3 times y becomes 3y. And 3 times 2 becomes 6. And of course, all of that equals to 48. And similarly, in our second equation, as we distribute the 3 by the 2 terms in this first parentheses, I get 3 times x, which is 3x. And then 3 times 3, which is plus 9. And then negative 2 times x, which makes that a negative 2x. And negative 2 times negative y, which becomes positive 2y. This is why it's important not to forget the parentheses here, so that way you won't forget to distribute your numbers by both terms. 2y. And that is going to be equal to 18. Let me again stop here for a second, make sure everybody's okay so far. So all we have done so far, after we eliminate the fractions, we then try to eliminate all the parentheses, which we do that by distributive property. So now if you see any like terms on left-hand side of both equations, you will combine. So obviously there is no other x term, so the 8x will remain as 8x. And then negative 4 plus 6, which will add up to be negative 2. Negative 4 plus 6 will be negative 2, which will be on the left-hand side. So we move it to the right, which become plus 2. And 48 plus 2, of course, will add up to be 50. Let me repeat that one more time, how I got 50. So as you combine negative 4 plus 6, that adds up to be positive 2. And of course, actually, I do apologize. As 2 goes on the other side becomes negative 2. So sorry about that. I'm glad I repeated it. So that becomes actually 46, which is 48 minus 2. So let me say one more time. Negative 4 plus 6 becomes positive 2. And as you move it over, it becomes negative, or subtract 2 from both sides, that becomes minus 2. And 48 minus 2 becomes 46. And of course, the 3y on the left will still be there. So there it is. So now you can see your first equation all the way from here. Now it has turned into the exact structure that we wanted to have, which is 8x plus 3y equals to 46. So now we have to also clean up this one, second equation, so we can have the same structure again. And in the second one, you have 3x minus 2x, which will just simply become x. And then, of course, your 2y is going to be still there. And then, of course, as you move the 9 over, 18 minus 9 becomes 9. Okay, so now we are ready to decide which variable we have to eliminate, which is that, of course, 100% up to you. In this case, I'm sure, as you know, to be able to eliminate any of the two variables, x or y, you have to make sure, of course, that the coefficient in front of that variable, like in this case, if you want to eliminate x, then you have to make sure that if this is 8x, that second coefficient on the x in your second equation, its coefficient becomes opposite, which is negative 8, so that when you add them, basically you eliminate the x, hence the name elimination method, right? So let me repeat that one more time. So in order, if you decide to eliminate x, for example, which is your decision, you can do y or x, but if you decide to eliminate the x, in this case, all you have to do is make the coefficient of x in your second equation to become negative 8, which is opposite of 8. And then when you add them, of course, negative 8 and 8 will cancel each other, and hence you have eliminated the x. Now, if you were to eliminate the y, you would have to do 2 steps multiplication, because you would have to make both 3 and 2 to become the same number, and that will take basically 2 steps instead of 1 step if you don't want to use fractions. So in this case, I'm going to go ahead and eliminate the x, which means I'm going to multiply both sides of our second equation with negative 8 on both sides. And then after that, we can add them together. Okay, so I think I have just about enough room to be able to do that step. So I think you can hopefully handle that just from my verbal explanation. So let me just say it. So first of all, as you distribute the negative 8 by x, that becomes negative 8x. When you add it to 8x, oh, I forgot to say, now we're going to add the two equations together. So negative 8 times x becomes negative 8x. As you add it to 8x, of course, it gets eliminated. Negative 8 times 2 becomes negative 16y. And negative 16y plus 3, which become negative 13y. Okay, so on the right hand side we have 46 plus 9 times negative 8, which is of course negative 72. So the right hand side becomes 46 minus 72. I'm going to go ahead and move this on top so we can see it better. So from there we have on the left hand side negative 13y equals 46 minus 72, which I believe is negative 26. So to solve for y, we'll divide both sides by negative 13. And on the left hand side, of course, we'll have y. And negative 26 divided by negative 13. Of course, negative over negative positive. 26 divided by 13, which becomes positive 2. So there is your y value. As I mentioned earlier, you can take this y value of 2 and plug it in any of those equations that we have in our system, original system, or even the other equations that we got by manipulating the original ones. And you will get exactly the same value for x, regardless of which equation you replace the y value with. Okay, so I'm going to go ahead and choose this one. As I mentioned before, this is the easiest one, of course, to play with. Again, that's before we multiplied both sides by negative 8, which was the equation x plus 2y equals to 9. And this is a perfect one because the x, as you can see, is by itself here. And of course, that is the only unknown left to be found, which is x. So that's why that one would be the best choice, okay? So I'm going to go ahead and erase the next two lines here under the y value of 2. So we can go to this equation and replace the y with positive 2 and solve for our last unknown, which is x. Gianna, can you pass me the eraser, please? Thank you. My granddaughter helping me. So let me just erase these two lines here so we can finish it up by looking for x, which will be our last unknown. Okay, so we're going to take this equation and the value of y equals to 2 and replace the y with 2 in that equation. So that becomes x plus 2 times y, which of course is going to be replaced by 2, equals to 9. Don't forget that was before we multiplied both sides by negative 8. 2 times 2 is 4, so that becomes x plus 4 equals to 9. And to isolate x, we'll subtract 4 from both sides. And so x becomes 5. And we just solved our system of two linear equations with two variables. Most of the time, the solution is written as an order pair. So you may see it in the back of your book as solution equals to the set with the order pair. Of course, like x value, which is always your first coordinate. We found it to be 5. And our second coordinate, which is the y coordinate, which happened to have value of 2. Let me just move this over a little bit so you can see it better. So the solution will be written as order pair 5, 2. Okay, I hope that helps. Thank you.